Question 7, we have by first expanding cos theta plus sin theta square, find the three solutions. Now we have the three solution of this equation for 0 less than theta less than pi. So by expanding, we have the hint here. So cos theta plus sin theta and the square. So I am using here the formula of a plus b square, which is a square plus 2ab plus b squared, right. So a square, a is our cos here, cos square theta plus 2 cos theta sin theta or sin theta cos theta, the same thing, plus sin square theta, right. So now this one I am just combining cos square theta plus sin square theta plus 2 sin theta cos theta is equal to 1. This all is given to us as 1, right. So this one is 1, sin square plus cos square is 1 plus 2 sin theta cos theta is equal to 1, right. This 1 and 1 gets cancelled. So we have sin 2 theta. Now you see we have this sin 2 theta. Sin 2 theta, the formula of sin 2 theta is 2 sin theta cos theta. So this is equal to 0. Now 2 theta is going to be sin inverse 0, right. So now the graph of the sine, as you know, it is, if this is a 0, so it's like this, right. So here is 0, then we have pi here and 2 pi here, okay. So then we will have theta from here 0 degree, when is sin 0, at pi and then at 2 pi. So 2 theta is 0 and then pi and then 2 pi, right. And theta divided by 2, 0 over 2, 0 degree, the 0, sorry, then pi over 2 and pi. So these are our three answers for the angle between 0 and pi, right. Now part 2, hence verify that only solution of the equation is r 0 and half pi. So we have cos theta, we are given the equation cos theta plus sin theta is equal to 1, right. So we are looking for theta when it is 0. So when theta is 0, so then this is cos 0 plus sin 0, cos 0 plus sin 0 equals, cos 0 is 1, sin 0 is 0. So this is equal to 1, which is equal to right hand side. So hence theta is a solution, right. Now for theta equals to pi by 2, pi by 2, this is half pi. So this is going to be cos pi by 2 plus sin pi by 2. So cos pi by 2 is cos 90, that means cos 90 is 1 and cos 0 is 1, cos 90 is 0 and sin 90 is 1. So this is again 1, which is equal to right hand side. So hence pi over 2 is the solution of this equation. Now let's try, we had the value of theta also pi. So when theta is pi, then this equation is cos pi plus sin pi. Cos pi is -1, sin pi is 0. So answer is -1, which is not equal to right hand side. So hence this is not the solution is only 0, and so we can write down 0 and half pi is the only solution, right. Now next one, we have part B, prove that this identity. So to prove this, you have to be very patient. You see there are so many things here. So we will start with the left hand side. Left hand side, if I take LCM here, we have cos theta plus sin theta, cos theta minus sin theta, okay. So then this is going to be sin theta into this whole thing, cos theta minus sin theta, minus, then we will have 1 minus cos theta, and this is cos theta plus sin theta. So now when you expand this will be sin theta, expand the brackets, sin theta cos theta minus sine square theta. Then we have minus here. Let's first open this one, expand this one. 1 will be multiplied to both, cos theta plus sine theta minus cos square theta minus cos theta sine theta, right? Now over expand this also. This is going to become cos square theta minus cos theta sine theta, then plus sine theta cos theta minus sine squared theta. Sine theta cos theta is okay, let's just first open the bracket. Sine theta cos theta minus sine squared theta. Be patient guys for doing these calculations. One single mistake can sometime cost a lot. So open the bracket, the sign is going to change. So this is cos theta plus sine theta. Sorry, again see, this is minus, because we are opening the bracket now here. So plus cos square theta and plus cos theta sine theta. So now here down we have cos square theta and sine squared theta. If you see this cos theta sine theta, this is sine theta cos theta the same, so this is cancelled with it. So we are left here in the denominator cos square theta minus sine squared theta, right? So now let's see the numerator, cosine theta cos theta here, and then we have sine theta again. I think this is positive sine theta cos theta, then we have sine squared theta cos theta plus sine theta. We had negative sign here, sorry guys, you see there is plus sign here, sorry. So this is plus, so all the signs are going to change here, extremely sorry. So this is going to become plus let me just recheck everything. Sine theta cos theta minus sine square theta plus cos theta, this is going to be plus sine theta minus cos square theta minus this was cos theta sine theta over denominator, this one, right? So now sine theta and cos theta, this is cancelled, and if we see here we have cos theta, now this one here I am writing this first here, cos theta and sine theta. So this is cos theta plus sine theta, then we have minus, if I combine this and this, so taking minus sign outside, sine square theta plus cos square theta over as our answer you can see in the denominator we have sine, so we will replace this cos by 1 minus sine squared theta. Minus sine square theta already is there, right? So then we will have this cos theta plus sine theta minus 1, sine square plus cos square, this is 1, right? So over we have 1 minus 2 sine squared theta. I think that's the answer. Yeah, this is equal to right hand side. You see here cos theta plus sine theta minus 1. So this is equal to right hand side. Okay. Now part C, using the results of A, 2 and B, like above results, solve this equation. So now as this equation, we solved this one in the previous part, I am just taking this one from here. This is equal to cos theta plus sine theta minus 1 over 1 minus 2 sine squared theta, right? And this is equal to we are given, we have to solve this, right? solve this equation, and this is equal to this right hand side 2 cos theta plus sin theta minus 1, right. So now we will have this one cos theta plus sin theta minus 1 over this, and I am like, if we take this one, so I can bring this down here, you see this and this is same, so I am going to write it down cos theta plus sin theta minus 1 over, bringing this on this side, this one, this whole term, this is cos theta plus sin theta minus 1. So this is the whole thing, and equals to, we I'm shifting this to other side, 1 minus 2 sin squared theta over 1. Now this whole thing gets cancelled with this, so that means, which gives us 1 minus 2 sin squared theta is equal to 1, right. So then 1 minus 1, bringing this to this side, 2 sin squared theta, sorry, there is 2 was here already. So this is 2 minus 1, this is 1 over 2 equals to sin squared theta, right. So now what we will have here, sorry guys, let me redo from here, seems there is some mistake down here. So this is going to be 1 minus 2 sin squared theta is equal to 1 over 2. Now it's correct. Negative 2 sin squared theta is equal to 1 over 2 minus 1, right. So sin squared theta is equal to, this one is negative half times this, bringing 2 to other side, this is also negative half, which is 1 over 4. So sin square theta is 1 over 4, then sin theta is going to be plus minus half, right. So taking this value, we need to find out the value of now theta. So now we have here sin squared theta is plus minus half, so from here sin theta is half and sin theta is negative half, right. So when is sin theta half? When it is pi by 6 and 5 pi by 6. Similarly here in this side we have theta is negative pi by 6 and 7 pi by 6. So this is our final answer. These are the angles, right. Now question number 8, we have here the graph. The diagram shows the graph of y equals to fx, where the function is defined by fx equals to 3 plus sine 1 by 4x for 0 to 2 pi. On the diagram above, sketch the graph of y equals to f inverse x. We are looking for the f inverse x. So for f inverse x, it is going to be the reflection in this is going to be reflection in y equals to x, right. So y equals to x is the line here, so we are going to join these points. It's not, sorry guys, wait, joining these line. It's hard to draw guys like this, but you will have ruler, right, you can easily draw this. So now this is going to be the reflection in this line. So let's see, the reflection is going to be like, this point will be here and this point is like 1 square and then 1 down, 1 square and then a little bit here. So it's going to come like this, Okay, then this is pi and this is pi, little less than pi, and then we have, let's say, this point is 3 by 2 pi, 3 by 2 pi here. So somewhere here like this. So this is your reflection. This is the graph of f inverse x, right? Now next, find the expression f inverse x. So we have fx, which is 3 plus 2 sine 1 over 4x, right? So f in, let's say this is equal to y equals to 2 then sine 1 over 4x. So this is y minus 3 equals to 2 sine, go step by step, 1 over 4x. So then this is y minus 3 over 2 is sine 1 over 4x, right? So then we will have 1 over 4x, this one shifting sine on other side will become sine inverse. So y minus 3 over 2, and then x is going to be, we are making x the subject actually. So this is going to be sine inverse y minus 3 over 2, right? So then we will have here f inverse x. Now f inverse x, just change right hand side, x minus 3 over 2. So this is your final answer of f inverse x, right? Now part C, we have this diagram here. The diagram above shows the part of the graph of gx. This is gx, 3 plus 2 sine 1 over 4x for the angle. Now angle is different here, the range is different here. So this one, complete the sketch of gx on the diagram. So now let's complete this one. We have negative 2 pi to 2 pi. So 2 pi we have here, the negative part is not there. So we will take the all these values at 2 pi, then we have half pi. So and I will start with this one, negative 2 pi, negative pi by 2. So g of negative pi by 2. So I'm just using my calculator here. So I'm getting here, this is the value 2.25, right? Then g negative pi, g minus pi, this one we are looking for now, this one, g minus pi. When you do this, this comes out to be 1.99. Just use your directly the calculator. Now negative 3 pi by 2, g of negative 3 pi by 2, this is 1.15, right? Then g of negative 2 pi, g of negative 2 pi is 1, right? So now we don't know, this side also we have the pi and other these things. So now pi, the value of pi is 3.14, right? Pi is 3.14 as we have the numbers here. So this one is 3.14, right, this point. Then we have 2 pi, 2 pi is going to be times 2, 2 pi is 6.28, right? So that means this point is 6.28, okay. Then negative 3 pi by 2 is going to be, if you calculate, and pi is 3.14, and half of this is half of 3.14, which is 1.57, and this is half midpoint of this one, that is 1.57. This comes out to be 2.35, and this comes out to be 0.79, this one, this point here, right? So we have these values here. Now g negative 2 pi is 1, negative 2 pi is 1 is here somewhere, this is 1.57, so little bit down here. So this is done. Then 1.15 is somewhere here, no, this is down, sorry. So this one is 0.7, little above that. Then 1.15 is down here somewhere. These are the rough sketch, you know, you can't make exactly the same. So 1.199 is going to be negative 3 pi by 2 is done, and this 3 pi by 2 is here. not this one. Negative pi is 1.99 somewhere here. So basically it's coming like this. If you see, sorry, so just join these points like this, somehow like this, right? So then we will have what is the next part? Complete the sketch and above and explain whether the function g has an inverse. So now for having the inverse, if you see, this is a single diagram. If we apply horizontal line test, if I take this horizontal line, there is only one point here, right? This horizontal line here, it meets only at one point. So there is no point where we have the two outcomes. So this horizontal, according by the horizontal line test, according to the horizontal, it passes the horizontal test. So this is a 1 function, this is 1 function and is increasing, and also it is increasing. So therefore it does have an inverse, right? So now next D part, describe fully the sequence of 3 transformations. We have 3 transformation now, which can be combined to transform the graph y equals to sin x. So our transformation is y equals to sin x to fx, y equals to fx, and fx is 3 plus 2 sin 1 over 4 x. Now if you see, if you want to see the 3 transformations, let me just change here the color. So one transformation is here, you see, another one is here, the third one is here, right? So that means we will have the different transformation, series of transformation. So the first one we have here, the stretch. So what is stretch? Stretch is like this one, you see 1/4 here. So 1/4 here. So the x coordinate here, it was x, now x coordinate is x over 4. So this is a stretch with stretch factor of 4. So this is stretch factor of 4. So first transformation we are going to write down. This is stretch with the stretch factor of 4 in x direction, as the x value is changing, right? So this one is done. Now second, we will have the stretch again, but now you see this one here, this 2 here. So this is the value of y. This was sin x, now this is 2 times sin x. So now this is again, we will write down, this is a stretch with the stretch factor of 2 in y direction, right? So 2 are done. The third one we have here 3 is plus, so sin x plus, so something is like this is now the change in the value of the y. So this is a translation along vector 0 and 3. So these are the 3 different sequences. So this is 6 marks question. You have to be careful while writing these stretches. Thank you so much, guys. We'll see you in the next video. Kindly subscribe to the channel if you are getting benefit of the videos, and also press the like button. Be blessed, guys.